Alright, year 10s. Today we are looking at the distributive law and surds. This is binomial expansion with surds. Looking at example A. Remember, with binomial expansion, where there are two terms in each bracket, we're going to end up with full multiplications. So we have 3√3 times 2√3. We have √3 times -5. We have 2 times 2√3. And we have 2 times -5. We simplify. √3 times 2√3 is going to be 2√9. Minus √3 times 5 is 5√3. 2 times 2√3 is plus 4√3. And 2 times 5, we're going to end up with -10. Again, we simplify. So, here we have 2√9. The square root of 9 can't be simplified. The square root of 9 is 3, so 2 times 3 is 6. We have minus 5√3 plus 4√3. These are like terms, so we can simplify. You have minus 5 plus 4, you're going to end up with minus 1√3. Then minus 10. Finally, we have two constants. We have 6 minus 10. So again, that can be simplified. We will end up with 6 take away 10 being minus 4. So we end up with minus 4 take away square root of 3. Alright. The first step, and the hardest step, is writing out all your multiplications. Okay? Making sure they have the correct symbols. Once you have that correct, it's just a matter of simplifying. So, with example B, we have 6 times 3√2. We have 6 times -1. So negative 6 times 1. We have -√2 times 3√2. And then we have -√2 times -1. Negative times negative will be a positive √2 times 1. And then we simplify. If we have 6 times 3√2, only the 6 and the 3 will multiply. So we end up with 18√2. Minus 6 times 1 is minus 6. Minus √2 times 3√2 is 3√4. Plus √2 times 1 is just √2. Simplify again. So here we have 18√2 plus √2. So 18 plus 1 is going to leave us with 19√2 minus 6. Now where we have 3√4, the square root of 4 can be found. It can be simplified. The square root of 4 is 2. So minus 3 times 2 will be minus 6. Finally, we have two constants, minus 6 and minus 6. And if you have 19√2, if you take away 6 from -6, you'll end up with -12. That is your final solution. Alright, this is we're going to start looking at our quadratic expansion. Alright, so here we have a perfect square. You'll remember that if you have a plus b squared, that equals a squared plus 2ab plus b squared. So we're going to use that formula here to save us some time. Our a value is √5, our b value is 3. So a squared will be √5 squared plus 2 times √5 times 3 plus 3 squared. We simplify. Root 5 times root 5 is 5. 2 times root 5 times 3 is 6 root 5. And finally, 3 squared is 9. We have a 5 plus 9, which will end up being 14 plus 6 root 5. Looking at B, we have A plus B, A minus B. Which is a difference of type of squares or dots, and we know it simplifies down to A squared minus B squared. This saves us a lot of time with our expansion. We're going to end up with the square root of 3 squared minus 2 squared. Square root of 3 times the square root of 3 is 3, minus 2 squared is 4. It will become the final solution of negative 1. Finally, find the area of this triangle in expanded and simplified form. So we are using your area equals half times base times height. So your base is root 7 plus 5 and your height is 5 root 7. So first thing we do is substitute. We have a half. Use brackets to contain the full expression. The base is root 7 plus 5 times 5 root 7. Alright, now you can do this a couple of ways. I'm going to carry out the multiplication of 5 root 7 and the brackets first. So I'm going to leave the half on the outside. So we have root 7 times 5 root 7. Plus 5 times 5 root 7. We simplify. That's a half. Root 7 times root 7 is going to be 49. So, root 49, which is simplified down to 7. So we have 5 times 7 plus 5 root 7 times 5 is going to be 25 root 7. Still leaving the half on the outside, that is going to give us 5 times 7 is 35 plus 25 root 7. And finally, I'm going to end up putting all of that over 2. Yeah? To account for the half. So we're going to have 35 plus 25 root 7 all over 2. That is your final answer for the area. Make sure you give it a subject so that you know what you have found. And that is the final sheet that you need to complete by Monday of next term. Alright, if you have any questions, please message me on Edvoto.